Have you ever thought about living forever? I'm not talking about your body, but your mind. Your thoughts, your memories, your entire self uploaded to a computer. It sounds like something straight out of a movie, but some of the smartest people on the planet are actually working on making it a reality. So how close are we really?
So, there's this movie, Transcendence. In it, a brilliant scientist is dying, and right before he does, his team uploads his consciousness to a quantum computer. And once he's free from his body, his intelligence just explodes. We're talking about healing the sick, controlling technology all over the world, even rebuilding his own body. But of course, as he gets more powerful, people start to see him as a huge threat to all of humanity. Now, this wild movie plot, it's actually based on a very real and pretty heavily debated idea. It's this hypothetical point in the future that technologists and futurists call the singularity.
So what is the singularity? Well, the term itself is actually borrowed from physics. It's used to describe the center of a black hole, a point where our understanding of physics just completely breaks down. And in the world of technology, it means something similar, a future where progress gets so fast and so complex that it's just beyond human control, or even our ability to understand it. Okay, so why do some people think this is bound to happen? It's because technology doesn't just improve in a straight line. It's not 1 plus 1 plus 1. It builds on itself. It grows exponentially. You've probably heard of the most famous example of this, Moore's Law. Way back in 1975, Gordon Moore, one of the co-founders of Intel, predicted that the number of transistors, you can think of them as the tiny little nerves of a computer, would double about every 2 years. And for decades, he was unbelievably right. This one observation is basically why you have a supercomputer sitting right there in your pocket. And this little chart shows the difference perfectly. Linear growth is steady, predictable, like taking one step after another. But exponential growth? Whoa, it's a rocket launch. Every single jump is bigger than the one before it, until things get explosively fast. In fact, each new doubling is equal to all the previous steps combined. And it's this kind of curve that has futurists convinced we're getting close to some kind of major tipping point. So where does this all put us on the timeline? Well, the futurist Ray Kurzweil, in his really famous book, The Singularity is Near, actually put a date on it. He predicted that by the year 2045, the power of artificial intelligence will blow past the intelligence of all humans combined. Just let that sink in. For a lot of us, that's well within our lifetimes. Kurzweil also said that the singularity would be all about merging human brains with computers. And this isn't science fiction anymore. It's actually happening right now with a technology called brain-computer interfaces, or BCIs. So how in the world is that even possible? How can our thoughts, which feel so abstract, right? How can they actually control a physical thing, like a cursor on a screen or even a robotic arm? Well, in principle, it's pretty straightforward. Your brain is basically an electrical machine. Every single time you think about, say, moving your hand, your brain fires off a very specific pattern of electrical signals. A BCI is designed to do just one thing, use tiny electrodes to read those signals and then translate them into a digital command that a computer can understand. And you can't talk about this technology without talking about Elon Musk's company, Neuralink. Their approach is incredibly ambitious. They're not just reading signals from outside the skull. They are developing a tiny chip that gets surgically implanted directly into the brain. And the demos they've shown publicly have been absolutely stunning. We've seen a monkey playing a video game using only its thoughts. We've seen a chip controlling a pig's leg movements in real time. Now, the stated goal is medical, to one day cure things like paralysis, blindness, deafness. But the technology itself, well, it opens the door to that whole sci-fi dream, a direct, super fast link between our minds and machines. Okay, so if we have the technology starting to link brains and computers, what's the holdup? Why can't we just upload a mind? Well, we've just run into the single biggest hurdle in this whole quest, the absolutely mind-boggling complexity of the human brain itself. To even try and get the challenge here, you have to appreciate the scale. Your brain has something like 100 billion neurons. And that isn't just a big number. That's more than 12 times the number of people on planet Earth. And every single one is its own little biological computer. But honestly, that's not even the most complex part. Each one of those neurons can form thousands of connections, or synapses, with all its neighbors. The total number of connections in your brain is estimated to be around 1,000 trillion.
1,000 trillion. That's the network we would have to map. To put that number in perspective, scientists will often say that the ridiculously intricate web of connections inside your skull is about as complex as the number of stars in our entire Milky Way galaxy. Yeah, that's what we're talking about, trying to map and recreate. So yeah, the point is, we just don't have the technology for that yet, not even close. To simulate just a tiny fraction of a rat's brain, scientists needed a supercomputer thousands of times more powerful than your laptop. And storage? You'd need the equivalent of about 10 million of Google's massive server farms just to hold the data for one single human mind. But hey, let's imagine for a second we solve all of that. Let's say we have quantum computers, unlimited storage. We perfectly map all 1,000 trillion connections. That brings us to the final and maybe the unsolvable problem, the mystery of consciousness itself. We all know what it feels like to be conscious. It's your sense of you. It's your feelings, your experience of the color red, the taste of chocolate, the feeling of sadness. But scientifically, we have no idea how these experiences pop out of a bunch of electrical signals firing between neurons. It's one of the biggest unsolved mysteries in all of science. And that brings us to the ultimate question. If we create a perfect digital copy of your brain, a bit-for-bit replica of its entire structure and all its data, is that copy really you? Or is it just a perfect simulation, a really sophisticated robot that just acts like you, has your memories, but there's nobody home? This is the true barrier. It's not just a technical problem anymore, it's a deep philosophical one. We just don't know if consciousness is something you can copy and paste like software, or if it's something that comes from our living biology in a way we don't even begin to understand yet. So you have to wonder, if we ever do succeed, if we finally transcend our biological limits and merge with the things we create, what will it even mean to be human?